welcome to chapter 13 of the Java tutorial, which is about references, or more specifically about working with reference data types, which are objects and arrays, both of which we have discussed in the previous chapters already. So, let us look at a small example. We see here a public static void main method which is doing some calculation. So we start with the declaration of some integer variable I that we initialize with value 3. Then we introduce a second variable j and we assign to it the value which is currently in I. And now in this third line of code we say j is equal to 2 times j. So we multiply j with 2 and the result will become the new value in that variable j. So, and what we do next is simply that we output the current value in I and in j. And of course you may ask yourself, first of all, what output would you expect in this situation? Well, this is maybe not a difficult question actually. Of course, well, the value in I is still 3 because we have only in this first line of code we have assigned some number to I, so the value in I is still 3, but the value in j is 6. And that's precisely what we get if we execute this program. There's nothing surprising here. However, well, to summarize, we see that changes of this variable j, of course, they do not affect variable I. So they don't have any effect on the variable I. Now let us look at a slightly different example. So what we are doing here, first of all, we are introducing an array I of type int. Well, this array we kind of visualize as a container. Yes, so a container that can contain multiple variables, multiple values. Here we take a container of size 1. So only this single number 3 is in this container I. Now what we say is, okay, let us introduce a second array, j, and we assign to it, we initialize that array with I. Now it seems we have these two arrays, I and j, both of which contain just one element with value 3. That is the current situation after executing these two lines of code. So now what we are doing next is we are taking the first element in j, j0, and multiply this with 2. Well, okay, first value in j is of course 3, multiplied with 2 should be 6, and this value 6 we assign here to the first position of j. Okay, so now again we have these two variables I and j. In the third line of code we just multiply this first value within j with 2 and the result is then assigned to that first position of j. And now what we're doing here is that we are again reporting the current value in I and j, namely at the first position of each of these arrays. And now something really interesting is happening. So basically what we retrieve then as output is that the value of I0 is 6 and the value of j0 is 6 as well. Meaning, with this command here, both the first value in I and in j has changed. Not only in j. Also, I contains now value 6 instead of value 3. And this might be a little bit counterintuitive for the moment, because when we worked with these primitive data types, like int in particular, we had a completely different result. So this line here, this third line of code, affected only this value within the variable j. But now we see this multiplication here with factor 2 has an impact on both array I and array j. So changes of j0 also change I0. And why is that? So let me visualize this, what is happening here actually. Yeah, so what we do actually, if we create this array I, we are creating a variable I which is a reference to an array. Yeah, so I is just a reference to an array which in our situation contains just one element. Now, with this second assignment here, int j equal I, what we are doing here is we are not creating a new array. Rather, we take that array which is referenced by I, and with assignment here now, after this assignment, j will refer to the same array as I. Yeah, so that is happening with this assignment. We just read out, so to say, variable I, meaning we look at what is the array referenced by I, and with this assignment then afterwards, j will refer to the same array. And now, with this line of code here, we are reading out the value in the first cell of that array. We multiply it with 2. We assign the result here again in the first position of array j, and accordingly we will have then value 6 in that array, which is referenced both by variable I and variable j. So now if we report the first element of I and the first element of j, in both cases we will get value 6. So that is basically how working with arrays works, how assignments of these variables work. So to summarize, an array is a so-called reference data type. Yeah, so this variable I can be seen as a reference to this container, which is somewhere in the memory of the computer. So I is a reference to the memory where the array elements are stored. And with assignment here, j equal to I. Yeah. So after that assignment, j will refer to the same place in the memory. It just will refer to the same array. So we do not create a copy of that array in particular. It's just that j and I are now referring to the same array. And then, of course, if we change the value at some position of j, at the same time also the value at the same position in the array I will be changed, because in fact there is just one array. So that is important when working with arrays. Well, as an example, working with objects now instead of working with arrays. It's a very similar example, I should say. What we are doing here is we are creating a new object of type point. We use the constructor of the class point for this, and we instantiate the point with coordinates 2 and 0. And now we introduce a second point, q. We declare q, and we say q is equal to p. And again, with that we do not create a copy of point p. Instead, what we are doing is that we look at, okay, what is the point in the memory of our computer that variable p is referring to, and with this assignment, q equal p, q will afterwards refer to the very same instance in the memory. And now it's no surprise anymore that if we say now, for example, q dot set x value 3. So now we would like to set the x coordinate of point q to 3. Then this will not just change the x coordinate of point q, but at the same time it will change the x coordinate of point p as well. Well, and if we now report here the coordinates of these 2 points using the system out println method, then you see this outcome. So we compile this Java class test with the javac command. Then we execute this main method by calling the Java interpreter for that class test. And then we obtain p as the coordinate pair 3, 0, and for q as well, 3, 0. Because with this setter call, we have changed the x coordinate of this one point object in the memory of our computer from 2 to 3. And accordingly, both point objects have x coordinate 3 after this assignment. So that means working with objects is quite similar to working with arrays. Both arrays and objects, they are actually handled by reference. So classes and arrays, they are reference data types. Yeah, just as an animation, again, what is happening in this example, it's quite similar to the animation for the array, I should point out. So with the first line of code, we have a new point object p. This is instantiated with this constructor, so coordinate 2 and 0. That is what you would obtain then. So we have a variable p, which is referring to some point object somewhere in the memory of our computer. Then with this second line of code here, we basically take point p, we look at which is the point referenced by this variable p, and with this assignment here, q will afterwards refer to the exactly same point object in the memory of our computer. So there is just one point still. And afterwards, if we now set the x coordinate, so you see the change happening here, we call dear point q, please set your x coordinate to 3. And what is happening then, in fact, we look at the variable q, we find out what is the point object in the memory that this variable q is referring to, and for that point object then the coordinate is changed from 2 to 3. And accordingly, for the point object p, the coordinate has changed as well. Well, to summarize, arrays and objects are members of reference data types. With this keyword new arrays or new objects are instantiated in the memory. But with an assignment, for example, this one, point q is equal p, we are not creating a new point object. We are just creating a new reference, q, to a point object that is already existing. Meaning, after this assignment then, both variables refer to the same object or the same array as in our first example in this chapter. Well, actually, this keyword new, that is always pointing out here, you are really creating a new object. There are, however, a few exceptions when new objects are created even without this keyword new. For example, we discussed the class string before. Here, for example, a new string can be generated also by putting this character sequence in parentheses. That is kind of the call of a constructor. You can see such a command like a constructor call. And similarly for arrays also, there's this very compact form to instantiate an array. So if we use these curly brackets and the values of the array within these curly brackets, then this has the same effect as creating a new object in the memory of the computer and filling this array with the numbers specified here in the brackets. So these are two exceptions where you are actually creating new data elements in the memory of your computer, meaning arrays or objects. But usually you can recognize the creation of new arrays and objects, or the instantiation. You can recognize that based on this keyword new. Well, for primitive data types, double, int, char, long, float, boolean, so just remind this one slide with the primitive data types which I have shown earlier. There actually, if we do an assignment like this here, we are actually creating a copy of the value. So we read out the value in B, and A will get the same value. But A and B are stored separately as two independent int numbers in the memory of the computer. So here we are actually creating copies of the data if we are working with primitive data types. And that's why I think this chapter is actually quite important to understand what is going on when you work with arrays and objects or primitive data types on the other hand. The first is by reference and the second is by value. So there you are creating copies if you do such an assignment, copies of the values within these variables. A little bit more about memory management in Java, or actually a topic that I haven't addressed so far at all. Let us look at this very short example. So we have a point object P instantiated like this, with the constructor call. Second, we have a point object Q. Again, we create a new point object somewhere in the memory of our computer, and then we do an assignment like this. So Q is equal to P, meaning we take variable P, we look at, okay, what is the point object referred to by P, and after this assignment, Q is referring to the same point object. So animating this, with the first line of code, you have something like this. You have a variable P, which is a reference to a point object somewhere in the memory. With the second line of code, you have this. Again, we call the constructor. With that, we allocate some memory in the computer to store this new point object with coordinates 1 and 2. And now, next, what is happening? We have Q is pointing to P. So with that, basically, we read out P, we look at what is the point object referenced by P, and Q afterwards is referring to exactly the same point object. So we have this situation now. Both variables P and Q refer to the same point object. And this second point object here is not referenced at all anymore. So there's no variable referring to it. Meaning this is now kind of lost data in the memory. So there is somewhere in the memory, there's this data, but no one is referring to it anymore. So this seems like a memory leakage actually, which is in some programming language actually a problem that you would need to handle explicitly. So you would need to actually free this memory explicitly in C++ or C, for example, to avoid that this data will now occupy your memory and block your memory for future allocations. So in Java, the nice thing is that if you have any such instance in the memory which is not referenced anymore, then there's a thing called the Java garbage collector, which automatically identifies parts of the memory that are not referenced anymore and the garbage collector will then free such parts of the memory to allow the reusage of those parts for new allocations. So this memory can then be used also for future initializations of variables, for future instantiations of objects, and so on. Yeah, otherwise you would have this memory blocked forever, or maybe until your program is terminated. But with the Java garbage collector, you have a very simple way to get rid of these occupied places in the memory that are not referenced anymore. Nevertheless, well, of course, it's nice that this garbage collector is there. Nevertheless, you should avoid code like this, of course. Yeah? So for what reason are you creating this point object Q here if in the next line of code you're just kind of leaving this instance alone in the memory without referring to it anymore? Yeah? So there's really no sense in doing something like this. So you could just skip this line of code, and thereby you would avoid the allocation of this memory. Also, the garbage collector would have less to do. It would be an increase in terms of efficiency. So avoid such unnecessary instantiations if possible. Okay, so that's it concerning reference data types, arrays and objects, and how to work with them. Thank you very much, and see you for the next chapter. Bye bye.